All right, let's start by looking at page 187. Go ahead and make sure your name is on it. First name, last name, number. And here's where we'll start. Lamar uses square tiles to make two rectangles shown below. Rectangle A and rectangle B. Number one, label the side lengths of the two rectangles. Okay, let's start there. Rectangle A, we usually do this side and this side. Okay, so let's start with here. The up. 1, 2, 3, 4, 5, 6. This has a side length of 6. 6 what? Well, 6 units, because we don't know. All right, and let's go across. We've already counted this one going up, but we have to count it going across too. 1, 2, 3, 4, 5, 6. All right, this is a 6 by 6, which makes it a square, right? Each sides are the same. All right, we did that one. Let's move to rectangle B. This side, and we'll do this side. 1, 2, 3, 4, 5, 6. It's the same length or how tall it is. 1, 2, 3, but it goes across 3 squares. All right. Number 2, write equations to find the areas of the rectangle. Do you remember the equation? Okay. So let's look at rectangle A. If area equals length times width, what's our length here and what's our width? Well, they're both the same. So the area is going to be 6 times 6, which means our area is going to be whatever 6 times 6 is. Okay, you're going to find that. If you don't know what 6 times 6 is, you're going to use some kind of strategy to count on. Okay, you could also do this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Isn't this a kind of count on too? 13, 14, 15, 16, 17, 18. Okay, and so on. When you get down here, that's going to be your area. Okay, it's going to be in square units. Let's look at rectangle B. If area equals length times width, we've got a 6 and a 3 here. Is it 6 times 3 or is it 3 times 6? Well, either way works, right? So I'm going to continue going with the up times over. So I'm going to do this. Now, if you've already started a list of 6s, wouldn't you be able to use that list again? You could. You could also do the same here and keep an add-on. Whatever you get here is going to be your answer. And it's going to be in square units. Okay, your paper should look like mine, except you're going to put your answer for this one here, and you're going to put your answer for here. Okay, go ahead and pause if you need to and work these problems. Number 3, Lamar pushes rectangle A next to rectangle B to make a bigger rectangle. So we're taking these two rectangles and we're pushing them together so that they make one big rectangle without any space in here. Okay, what is the area of the bigger rectangle? How do you know? So I'm just going to draw this one, rectangle A. I'm not going to put all the lines in it, okay? But I'm just giving myself a little reminder, okay? And instead, when I draw rectangle B, I'm going to draw it right next to, because this is the question they're asking. If I put them right beside each other and make a big rectangle, I'm going to use a different colored pencil so you can see. And I push them together and I make this rectangle. What's the area of this rectangle? when I push them together. Okay? How are you going to find that? You should know how many square units this one is because it's going to come from here. And you should know how many square units are in this one because it's going to come from here, right? And when you put these two together, you're pushing them together. What does together mean in math? It means this. When you put those two together, you're going to come up with something square units for the whole rectangle. All right, you work on that. When this is finished, I want you to turn it into the tray, making sure your name is on it and that you've done all of these steps. Don't leave the blanks here. I'm leaving them because you are finding the answer by yourself without me. This one too. All right.